Welcome to part 5 of the Koch Fractals in Unity tutorial by PeerPlay. In this part we will start with creating an audio visualization based on the Koch Fractals. There's just one more function that is very useful for our visualization system, and it is to be able to specify specific generations at start. In one of the previous parts we've binded the outwards and inwards generation to hotkeys, but we will now automate that process. So in the Koch line we've got these lines here, and we're going to remove these lines. But first of all, I'm going to copy this line, lerp position, and we're going to set the lerp position in the start function. And now let's remove these hotkeys. And we're going to save this script. Now let's go over to our Koch generator to create our start generation. And we will create this start generation with a new struct, and we'll put this underneath the generator animation curve. So let's type here, and we're going to type a public struct, and we'll call this the start gen. And let's open close this one, and we're going to add two variables, and the first variable we'll add is a public bool, and we'll call this bool outwards. And the second thing we're going to add is a float, and we'll call this the scale. Now we want to see the start generation in the inspector, so we're going to serialize it, and we can do this with system.serializable. Now we also need to declare this one, so we're going to say a public start gen, and this is going to be an array, and we'll call this start gen. Now this will create an array of the boolean outwards and scale, in which we can specify how we want to generate our generations at the start. So we need to initialize this into a for loop. So let's scroll down to the awake function, and underneath we're going to create a for loop. So we're going to say for int I is 0, I is less than the start gen, its length, I plus plus. Now what we want to do in this is call the Koch generate function. So we're going to say Koch generate, and we want to use the target position as input, and as a boolean we want to specify the start gen in its current position, its boolean outwards. And for the scale as well, we're going to get the start gen in its current position, and we'll get the scale. Now that should be all, so let's go back to Unity. And in Unity you'll see that we've got a start gen here, and we can specify the length. So let's say we're going to do one generation at start, so we'll get one more element, and we'll say that we either want to go inwards or outwards. I'm going to go inwards with a scale of 1. Well, let's test that out. Oh, there's already music playing, and we're going to make this work on music, but what we can do now is to select this lerp amount, and we can drag that inwards and outwards, and you'll see that it made the first generation. So now we've been using the lerp amount slider, but we can also connect that to music, so that's what we're going to do right now. And for the audio visualization we'll be using the audio peer class, which is the class I created. If you would like to follow along with this tutorial and you don't have this yet, you can either follow my tutorial on audio visualization, which you can find on my YouTube channel, or become a patron on my Patreon and get the full source code there. So let's make our Koch line react to audio. We're going to open up Koch line, and under the generate multiplier we're going to add a header, so we can specify that this is about the audio. So we'll call this audio. And underneath we'll type a public audio peer, and we'll call this audio peer. So we can reference in there the audio peer class that we've got. Now the next thing we need is an audio band on which we want this to run. So we're going to type a public integer, and we'll call this audio band. Now with these two variables in place, we can change the lerp amount. Instead of using this lerp amount, we can actually remove this or command this out. Now here we'll get the audio peer class, and we want to get the audio band buffer. And which buffer do we want? We want to get the audio band that we've specified. So let's get the audio band, close that one, and there you go. Let's save this and go back to Unity. Now you'll see here a nice header called audio, and we need to specify our audio peer class. So let's drag and drop that into there. Now let's use the audio band 1, which is about the kick. And with that in place, let's try out the scene. As you can see, it's already reacting to audio on the kick. Pretty cool, right? Now what we could do, for example, here is create 8 of these Koch lines for each of the frequency bands. So I'm going to set this to 000 position, and I'm going to create a empty game object, and we'll call this Koch lines. And let's make this a child of the Koch line, and let's copy paste this 8 times. Now we've got here one that's on the 0. We'll create this on audio band 1, 6, and on audio band 7. And now what should happen is that all these lines react to different frequencies. Let's see that. Let me actually change the camera position. So we're going to the camera. Let's rotate this camera into its Z-axis, I think. No, it's its X-axis. So we'll rotate this to 90 degrees downwards. Let's put this into a position. Let's set the background to solid color. Let's set this to black. So now another thing that we can do to extend our script is to look at how many initiator points this Koch fractal has. In this case 3 sides from the triangle, and we can make each of these sides react to different frequencies. So let's do that. And before we're going to make this react to different frequencies, let's change up our Koch line. So I'm going to remove all of these Koch lines, only this one I'll keep. Let's remove that, and let's change the shape to a octagon. And we're going to change the generator as well. And this first point is at 0.33, and we can't put keys at the same time, so we need to change that to something like 333, so it's not exactly at the same time but almost at the same time. So we can put that up here. If you put them at the same time, it will break the line and you have to redo everything. So now let's go to this key and we'll see at what time this is at. This is at 0.66, so let's set it at 0.666, and we're going to add another key in between of here, and we're going to set this to a time of 0.66 and a value at 0.25. Let's change this to both tangents to linear, and now we've got a straight curve. And in this case we're not going to use the Bezier curves, and we're going outwards. Now let's see that. I will place the camera to a little different spot to see it all. So we've got now these 8 different bars, and we're going to create that all these bars are going at a different frequency. And as we're having 8 different frequency bands, we can make all these bars react to a different frequency. So let's open up the Koch line again. So what we need to do is we need to create a different lerp amount for each of the initiator points. So we're going to add a private float array, and we'll call this the lerp audio. Now in the start function we'll create the length of this lerp audio to the initiator point amount. So we're going to say that lerp audio is a new float array with the length of the initiator point amount. Now as we're having multiple lerps, we also need to specify different audio bands to lerp on. So I'm going to change this integer to a integer array of audio bands, and we need to specify the length of that in the inspector itself. Now in the update function we need to divide our list of points by the amount of initiator points we have, and specify another lerp amount for each of these points in the list. So I'm going to create a new for loop, and I'm going to say that int I is 0, I is less than the initiator point amount, I plus plus. And we need to keep track in this for loop on which position we are at. So I'm going to create an integer and we'll call this count. This is just a temporary integer that we can use. Now inside this for loop we'll create another for loop in which we will divide our position's length by the initiator point amount. So let's create another for loop and we'll call this for int j is equal to 0 and j is less than the position dot its length minus 1 divided by the initiator point amount. And we'll put this into parentheses. And after that we'll do j plus plus. Now let's copy paste this line here and we can remove this for loop statement. And instead of using the lerp position I, we're going to use the count variable that we've got. And it's going to be lerping from position of the count to the target position count. And we're not going to directly use the audio pair, but we're going to use here the lerp audio. So we'll use lerp audio and we need its I position. Now we still need to set the lerp audio, so we're going above the for loop and we'll say that lerp audio of its position I is going to be and getting the audio pair class the audio band buffer, and we're going to get the position of the audio band of its position I as well. Let's close that. Now I made a little mistake with the count because I have to declare this as something to start on, so its start value is going to be 0. And now inside this for loop we're going to say that count is going to be plus plus. Now we're only missing the last point in the array of points, so we're going to copy paste this, and after all these for loops we're going to set its current count to the lerp audio, and that is going to be the lerp audio of its initiator point amount minus 1. And now with that in place we can save the script and go back to Unity. And in Unity you'll see here the audio bands with a size of 0, so we have to specify that ourselves. I'll set this to 8. You could create a custom inspector where if you select a different initiator then this amount will change directly. But for now I'm going to leave this at this, and you have to specify that yourself. So I'm going to set all of these bands to a different band. So this is going to be 1, 2, 3, 4, 5, 6 and 7. And now all the 8 different line sections should react to different frequencies. So let's see that. So now we can lerp our Koch fractals on different frequencies of audio. In the next part we will recreate the scene that is shown in the thumbnails of this tutorial, which is this scene. Besides the position lerping, we will also change the material colors of the lines and create a 3D scene with our line renderers. But for now I want to thank you for following this tutorial. If you liked this tutorial, leave a thumbs up, and to stay updated with new released parts, subscribe to the channel. If you would like to support me creating these tutorials for free, you can become a patron at my Patreon and get access to cool source code.